Hi guys, welcome back to In Case of Econ Struggles. Today we're talking about marginal utility and the marginal rate of substitution. Here are the questions we are going to answer in this video. If you would like to jump around, feel free to use the timestamps below. But let's get into it by talking about marginal utility. Now, marginal utility is the extra utility that I get from consuming one more additional unit of something. So it's the extra utility I get from consuming one more of a certain item. Now, marginal utility does not have to be constant over time. It often is not constant over time. We often say that we have diminishing marginal utility, but what in the world does it mean to say we have diminishing marginal utility? Well, to illustrate diminishing marginal utility, I'm going to use a classic example of the number of ice cream cones. So here I've got this graph. Notice that on this graph, the y-axis is not utility, it's marginal utility. And rather than use numbers, I'm going to use some faces to indicate feelings. So I like ice cream, so maybe I get my first ice cream cone and I'm really happy. I get a lot of extra utility from that. I get a second ice cream cone and I'm still happy about it, but I'm not as happy as I was when I got that first ice cream cone. Now by the fourth ice cream cone, I'm feeling pretty meh about the fourth ice cream cone. I'm not a whole lot happier with 4 ice cream cones than I was at 3 ice cream cones, so we would say that my marginal utility is diminishing. Now again, I've told you that this is marginal utility and not actual utility, but what does it look like on the actual utility graph? It's going to look something like this, where again, marginal utility is just the slope of the utility function. So here at my first ice cream cone, it's really high. By the fourth ice cream cone, my extra utility, or the change in utility with an additional ice cream cone, is pretty low. It's pretty close to 0. So what that means is that my utility function starts off pretty steep and gets flatter as I get more and more ice cream cones, which again is the same thing as saying that I have diminishing marginal utility. So this is a way you can kind of look at the utility function and sort of figure out whether or not you might have diminishing marginal utility. Something we often talk about when we talk about marginal utility is the marginal rate of substitution. All the marginal rate of substitution is the ratio of marginal utilities between two goods. So here, maybe our two goods are cookies and ice cream, or ice cream cones. So this part right here, this is the marginal rate of substitution between cones and cookies. It's the marginal utility of cones over the marginal utility of cookies. Now, something you've probably heard in your classes is that at the optimum of the utility maximization problem, this marginal rate of substitution is equal to the ratio of the prices, and that's going to hold in most cases unless it's some sort of fancy preferences or you have a corner solution. But most of the time, you're dealing with marginal rate of substitution equal to the ratio of the prices. And why is that? The way I'm going to explain this is using an arcade. So if I take this condition where the marginal rate of substitution is equal to the ratio of the prices and I rearrange it a little bit, I can get that the marginal utility over price for cones is equal to the marginal utility over price of cookies. The reason that is useful is because if we think about an arcade games take tokens. Now, if you're given a specific number of tokens and there are only 2 games at this arcade, the question is, how do you decide which game to play? How do you decide how many tokens to use for each game? Well, you're going to allocate your tokens between the 2 games such that when you get down to that last token, you're just as happy to play one game as the other game. So you say, okay, I've optimized, I'm using all my tokens as best that I can, and by using all the tokens as best that I can, that means that I am just as happy to play this orange game at the end with my last token, and I'm just as happy to play the green game with my last token. Now, maybe the green game costs 2 tokens and the orange game costs 1 token. So you're saying by the time I get to my last 2 tokens, I would be just as happy playing the orange game twice or the green game once, because you have equated the marginal utility of the orange game with respect to the 1 token to the marginal utility of the green game divided by the 2 tokens that it costs to play that game. So hopefully this makes marginal utility and the marginal rate of substitution make a little more sense, and then it also helps you better understand why the marginal rate of substitution is equal to the ratio of the prices at the optimum for most utility maximization problems. If it did, make sure to like and subscribe. If you're still confused, comment below, and we will see you next time for another case of Econ Struggles.